synthetic division, and we're going to use that to do a fairly practical thing, which is ultimately find the zeros or the solutions of any polynomial function. We'll start out with learning target 6, where we'll kind of give you a head start. We'll give you one of the factors or one of the solutions. But in the end, ultimately, we want you to be able to do all of this on your own. And so this is kind of one of the major lessons of this unit. We'll start out with a little vocabulary. And so the first thing is the factor theorem. And this is essentially something that you already know from the previous lesson, and that is that x minus k, okay, is a factor. In other words, k is a solution. So again, like using the zero product property, it would be the opposite of whatever we saw here in that spot. If and only if f of k is equal to 0. And so this is also a connector to the remainder theorem that we talked about in the last lesson. So that's just kind of another way of stating that. The rational roots theorem. So this one's a little bit long. And it says this: if p divided by q, so we got a fraction here, we don't know what that means yet, but you will, is a 0, or a root or a solution of a function, then p is a factor of the constant, the constant being the last term, that thing at the end that doesn't have a variable on it, and q is a factor of the leading coefficient. Okay. In other words, it's the coefficient on the first term. Okay, so you're kind of taking a look at the last thing, that's the numerator, and the coefficient of the first thing, that's the denominator. And so all of these kind of combinations of things that we could have are the possibilities for the zeros or the solutions of a polynomial. Okay, the fundamental theorem of algebra. Fundamental is a pretty good giveaway that it's a fairly important thing, and it goes like this. It says every polynomial function. So every polynomial function that you can think of degree 1. So that's pretty much everything. Linear functions, quadratic functions, cubic functions, all of these, all polynomial functions of degree 1 or more has at least one complex root. Okay, so in other words, when you graph any polynomial, it's going to cross the x-axis at least once. It might do more than that, twice, 3 times, 4 times, could be a whole lot of times. But it's going to cross at least once, and so it has at least one solution. The fallout from that is the number of zeros theorem. And this is usually what we think of most, and that's just that an nth degree polynomial so second, third, fourth, whatever, has at most n zeros, or n places where it crosses the x-axis, or n solutions. It might have less than that, but it has at most that many. All right, so let's move into some examples now. So again, here's an example. We're giving you a sort of one solution. We're actually just trying to determine whether or not this is a solution. So this is actually very much like what we did in the previous lesson with the synthetic division. Is it a solution? That means is x minus 1 a factor? Well, that means is 1 a solution? So we'll go ahead and we've got 2. Don't forget we've got kind of 0x to the third in between here. Looks more like a 2 of the third. So we've got 0, 2, 0, 3, negative 5, and 7. And so if my remainder is 0, well, then this is a solution, meaning this is a factor. If it's anything besides 0, well, it won't be. So we bring down the 2, and then we start doing our multiplication. 1 times 2 is 2. 0 plus 2 is 2. 1 times 2 is 2. 3 plus 2 is 5. 1 times 5 is 5. Negative 5 plus 5 is 0. 1 times 0 is 0. And so I wind up with a remainder of 0. And so this means no. X minus 1 is not a factor, and 1 is not a solution. All right, we'll try it again with a little bit larger one here. Things that we already know, at most, this can have 5 solutions. So it's a connection to keep in mind. We've got the 1 right here, and then we've got 3, negative 2, 1, negative 8, 5, and then 1. Okay, well, here goes. We bring down the 3. 1 times 3 is 3. Negative 2 plus 3 is 1. 1 times 1 is 1. 1 plus 1 is 2. 1 times 2 is 2. Negative 8 plus 2 is negative 6. 1 times negative 6 is negative 6. 5 minus 6 is negative 1. 1 times negative 1 is negative 1. And hey, it all turns out that my remainder is 0. And so that means that x minus 1 is a factor, okay? Which means 1 is a solution. One of the things that we'll be taking a look at here is if I factor out x minus 1, the polynomial that I would have remaining would be this right here. So I'd have 3x to the fourth plus 1x to the third plus 2x squared minus 6x minus 1. Okay, and so you can see that just piece by piece would be slowly but surely factoring things out from the big polynomial, getting that factored so that I could actually solve it or find the zeros. All right, next says find all rational zeros. So now I need to completely solve it or factor it, and factor into linear factors if negative 3 is a 0. Well, if negative 3 is a 0, that means I would have x plus 3 as a factor. But, kind of what's the rest look like here? So what we're going to do is we need to figure out what this polynomial is going to be. Well, what I can do is I can just go ahead and do the synthetic division. I've got the negative 3 here, and then I've got 6, 19, 2, and negative 3. All right, well, I bring down the 6. Now I've got negative 18, so positive 1. gives me negative 3, and 2 times negative, or 2 minus 3 would be negative 1. So give me positive 3, and of course my remainder is going to be 0 because, well, it said negative 3 is a 0, so my remainder should be 0. But the key piece of information is this right here. I've got now 6x squared plus 1x minus 1. And that would be the polynomial that I have left over. Now, can I factor this down a little bit? Well, I believe that I can. Do a little math and magic here. I got x squared plus x minus 6. Factor this guy, and I would have x and x. I'd have 1 positive, 1 negative. Factors of negative 6 that give me positive 1 would be 3 and 2. If I multiplied in by 6, I'd divide out by 6. And so, let's see, reduce these down if I can. So x plus 1/2. And then over here, I'd have x minus 1/3. So what it all comes down to is I got x plus 3. And then over here, I've got 2x plus 1 and 3x minus 1. So these are all of my linear factors. So this has been factored. And of course, now using the zero product property, I know that x has to equal negative 3. Obviously, that had been given to me originally. But I also have negative 1/2, and I have positive 1/3. All right, so that is factoring a big polynomial and finding all the solutions. But of course, this one feels just a little bit awkward, simply because, well, they already gave us one of the solutions. So at this point, we are going to need to figure out how do we do this on our own, not being given anything. And so here's how it works. We're going to have to go back and look at the rational roots theorem, or the rational zeros theorem. It means the same thing. Remember, that was the p divided by q thing. And remember, p was the one at the end. This was the constant, or factors of the constant, and q was the leading coefficient. Okay, so my possibilities for p are all of the factors of 2, which would include positive negative 1 and positive negative 2. The possible factors for my leading coefficient are going to be positive negative 1, positive negative 2, positive negative 3, and positive negative 6. And so, all of my possibilities, all of my possible solutions, not all of them will be solutions, but the possibilities are going to be all of these possible fractions. So, P over Q, my possible solutions, well, I just kind of go ahead and do all of them. 1 divided by 1 is 1, so positive negative 1. 1 divided by 2 would be positive negative 1/2. And then 1 divided by 3, positive negative 1/3. 1 divided by 6, positive negative 1/6. And then I'll go ahead and do it with the 2. 2 divided by 1 is 2, so positive negative 2. And then 2 divided by 2 is 1. I've already got that one, so I won't write it. 2 divided by 3 is positive negative 2/3. And then 2 divided by 6 would be 1/3, and I've already got that one. So clearly, this is too many possibilities. I can't have all of these as solutions. The most I can have is 4, and I've got 2, 4, 6, 8, 10, 12. And that's unfortunate. And at this point, it's kind of a guessing game. So which ones are solutions? Well, here's the strategy. You go ahead and graph this out on your graphing calculator. And in essence, this kind of gives it away because you're going to find all of the zeros or solutions when you graph it. So if you graph this one out, you would wind up with something that looked a little bit like this. And we'll be graphing all of these in the next lesson. So you can see it's got the 1, 2, 3, 4 zeros, and well, we just pick one as our solution. This one looks pretty convenient. Let's pick that. And so this is 1. So 1 is a solution. And so when I do this, of course, the remainder is going to be 0 because it's a solution. But we'll get the leftover polynomial. So we'll say 6, 7, negative 12, negative 3, and 2. And we do our synthetic division. So 1 times 6 is 6. Now I got 13. 1 times 13 is 13. That leaves me with 1. 1 times 1 is 1. It gives me negative 2. 1 times negative 2 is negative 2. And so I get 0. So now my factored polynomial is going to be x minus 1. And then I would have 6x to the third plus 13x squared plus x minus 2. And, well, I'm not really anywhere close to finishing it up. I still have a third degree polynomial to figure out. And so what I'm going to do at this point is I'm going to pick another one of my solutions and kind of do the same process all over again. I think negative 2 is going to be good to work with since these are both fractions. So negative 2 is another one of my solutions. So now it's going to look like x minus 1 and x plus 2. And then I got to figure out what else goes in here. So I do the synthetic division with what's left over here. So I've got 6, 13, 1, negative 2. So let's see here. Bring down the 6. Now I've got negative 12, which will give me 1. Negative 2 times 1 is negative 2. 1 minus 2 is negative 1. So I get positive 2, which of course gives me 0. But now what I have left is 6x squared plus x minus 1. And now I'm getting closer to something that I could actually factor. And so you guys saw my battery was dying, so we'll just go ahead and finish this off, assuming that you can factor that on your own. We would have x minus 1 as a factor. We'd have x plus 2 as a factor. And then this guy getting factored out would be 2x plus 1. And then the last one here would be 3x minus 1. And so my solutions wind up being x equals 1, negative 2, negative 1/2, and positive 1/3, which of course are all options up here. And of course you can see them here on the graph as well. So that is how you would solve any polynomial function. Next time we'll be using all of this information to help you graph